I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. So, in this lecture series of this subject, that is solid waste management, today I will discuss about the landfill gas contaminants and their removal. So, previously I have discussed about the landfill, and in landfill I have discussed about the types of landfill. Means two type of landfill will be there. Like that is, first is the like sanitary landfill, and other is the landfill for some hazardous waste. So landfill for MSW, and the next is for landfill for hazardous waste. So in this lecture today, I will discuss about the landfill gas contaminants. So what happened on a landfill? We will put the solid waste that is originating from any city. So after putting the waste on the landfills, what happened in the inside the waste? Some anaerobic reaction will start. On the microbial decomposition will start, and that microbes is going to biodegrade all the organic components of the solid waste. So due to this anaerobic reaction, many gas has been produced from this landfill. So first one is the methane, and second is the carbon dioxide. So production of methane and CO2. Both two gases are main gases that has been originating from the landfill. So this methane and CO2 is a dangerous gas because this methane and CO2 is the GHG, means greenhouse gas. Greenhouse gas. That's why this methane and CO2 is dangerous gas, and this is these two are the mainly originating from the landfills. So to collect this gas, or to collect the monitoring of the gas, already wells has been established on the landfill surfaces. Then after what happened, like we can utilize this methane and carbon dioxide for some electricity purpose. So direct use of collected raw landfill gas is impaired by gas contaminants like hydrogen sulfide will be there, siloxane will be there, and moisture will be there. So this methane we can utilize for some other purpose, but the problem with this utilization is that it will have some contaminants like hydrogen sulfide will be there. Like this methane is not purely, some content of hydrogen sulfide is there, some siloxane will be there, and some content of moisture will be there. So before using this methane gas, carbon dioxide gas for some electricity purpose or some in energy production purpose, this should have to be removed. Like this type of contaminants has to be removed. So in this lecture, we will study about the removal of these contaminants from the landfill gases. So to removal of these contaminants from the landfill gases, what methods are using, and by which method they are removing, and this type of contaminants has been removed. Because when we remove the contaminants, then only this gas will be much useful to study, to useful. Otherwise contaminants will be there, so it will affect the effects of these gases. Okay, so landfill gas needs to be treated due to its relatively high content of contaminants, because already landfills is having lots of contaminants will be there. So when the methane production will be ready, so in this methane some amount of H2S will be there, some amount of sulfur will be there, some amount of H2S and the sulfur is there. So these are the contaminants, and that contaminants will enter the landfill, and it will contaminate the vicinity of the area. And this treatment should be like two stages. This treatment of landfill gas will happen two stages. So two stages is followed for this treatment of landfill gas. What are the stages? First is the primary and secondary. In primarily, what we'll do two stage landfill gas treatment. Landfill gas treatment is done at two stages: primary and secondary. Okay, so we'll discuss about these two stages. So first stage is the primary treatment, and second stage is the secondary treatment. In primary treatment, what the methods are involved? So it will be consisting of removal of some contaminants, solids and liquids, and drying of the gas. So a little bit contaminants and like solids and liquids. Next, contaminants stage 2 will be there. This is called as advanced treatment. So in this treatment, it will be involve the desulfurization, means removal of sulfur, like removal of organic silicon compound, that is siloxane will be there, and removal of other gaseous contaminants like hydrocarbons and ammonia. So stage 2 is the primary treatment that will be required some initial treatment like some removal of some solids or liquids and the drying of gas only. On the other side, after completing the stage 1, it will goes to the stage 2. Stage 2 will involve some advanced treatment. So in this advanced treatment, it will be like some desulfurization will be there, and then the removal of organic silicon compounds and the removal of other gases contaminants like some hydrocarbons and some ammonia. So primary treatment, we'll discuss about the primary treatment. In primary treatment, what happens? It will be going to reduce the amount of contaminants in the landfill gas using simple physical process operation. So the contaminants has been removed from the gas, which will be like some very little physical process operation. So this physical process operation will involves the main contaminants are like water is there, some particulates is there. So two things are there, water and particulate matters. Water and particulate matters. So main contaminants that has been removed during this primary treatment is the some amount of water will be there, some amount of moisture will be there, and it will be referred to as a condensate particulates. Like same, some particulate matter will be there, and these particulate matter are small matters. So this should be having goes through the drying method. Next is the water condensate knockout. So how this water condensate knockout has been done? It is like the presence of liquid water in the landfill gas pipes works. So the presence of some liquid water will be there in the landfill gas pipe work, and that will be have some detrimental effects on the plant performance. So this water and condensate work knockout is like that. Some liquid water in there in landfill gas pipe works, and they have some detrimental effect on the plant performance. Accumulation of water reduces the space available for gas and raises the pressure loss. So what happened to these things? Like next is the accumulation of the water, and this accumulation of the water reduces. So this accumulation of water reduces the space available for gas flow and raises the pressure loss. So these two things are there in the water and condensation knockout is the presence of liquid water in landfill gas pipe works, and they have some detrimental effects on plant performance. Next is the accumulation of some water, and it will be going to reduce the space available for gas and raises the pressure loss. Depending on the source of gas in the application or proposed use of the treated landfill gas, three components can be treated. First is the liquid water capture, foam removal and vapor reduction. So depending on the source of the gases, means what are the source of gas and where it is going to be applied. Where this landfill gas has been going to be used, or it's a proposed use. So the three components can be treated. First is the liquid water capture, the foam removal will be there, and then vapor reduction will be there. Next is the siloxane removal. In this siloxane removal, silica has been removed. Silica has been bound with silicon has been bound with the oxygen molecule, bound with O2 molecule at the end. See, S is there, O, it has been bound with the O2 molecule, O2. So, this siloxane removal is very important because low molecular weight siloxane, it will be volatilized into the landfill area. So because of this siloxane method will be there where silica and sulfur has been removed with its oxygen catalyst, with its oxygen bond. So this removal is removing the trace contaminants from the biogas, so it can be reused rather than discarded, and the bioenergy yield is because of that, this bioenergy yield is going to be increasing rapidly. The most common biogas purification technology is adsorption and the use of aluminum, silica gel, activated carbons, geolites. The use of alumina, silica gel, activated carbon, geolites, and polymeric adsorbent have been reported for the removal of siloxane. So what happened? This biogas purification technology is the most common method is the adsorption. Adsorption has been followed. Adsorption method has been followed for the removal of contaminants from this biogas. And in this adsorption, what it is using, they are using alumina, silica gel, activated carbon, some geolite, and polymeric adsorbent, and it have been reported for the removal of siloxane. So adsorbent will be added, and as a adsorbent, what it is using some alumina, some silica gel, activated carbon is there. Next is the geolite. So these are the adsorbent that can be used in the siloxane removal. So this adsorbent will break down the sulfur from the biogas, and this purification technology is basically worked on the adsorption methods, and these are some common things that can be used as an adsorbent and have been reported. It has been reported for the removal of siloxane. Next is that when the gas is combusted to generate power, like in case of gas turbine, boilers, or internal combustion engines, so these siloxane are converted to silicon dioxide, SiO2. So, and that can deposit in the combustion or exhaust stage of the equipment. So silicons has been, that is the evidence of siloxane in landfill gas is found in the form of a white powder in a heated gas turbine components. So during the heated gas turbine components, this siloxane has been found, and that is this white powder means this is the evidence of siloxane. So next point is like that when the gas is combusted, when this gas is going to be combusted to generate the power. So in this gas turbine, boiler, or internal combustion engine, this will be combusted to generate the power. Then what happened? The siloxanes are converted to silicon dioxides, and this can be deposited in the combustion and sometimes the exhaust stage of the equipment. So this silicon dioxide can be deposited in the combustion and can be exhausted, or it may be at the exhausted stage of the equipment. So next is during the gas turbine components, so you can see that some white powder is there. So this white powder is like the evidence of some silicon. So this is the key methods that has been used for the removal of siloxane removal. First is the adsorption. Obviously adsorption is involved. So adsorption by using some activated coal, adsorption in the liquid hydrocarbon mixtures, and gas cooling with concurrent water knockout. So gas cooling will be there, that will be with some concurrent water knockout. A gas may be cooled down as much as to minus 70 degrees Celsius. So that will result into the 99% siloxane reduction. So gas cooling with some concurrent water knockout, and then the gas may be cooled down as much as to minus 70 degrees Celsius, and that results in 99% of siloxane reduction. Next is the advanced method. So in advanced treatments, it can be defined collectively as like secondary treatment, in which it is going to remove the generated emission like H2S. H2S is the hydrogen sulfide, siloxane, ammonia, some BTX, and halogens. Obviously, we are studying about the removal of some contaminants from this methane. So what is this contaminants? Is just like H2S, siloxane, ammonia, some aromatic hydrocarbons, and some halogens. Next is the hydrogen sulfide removal. Hydrogen sulfide is an extremely toxic and flammable gas. This has removal, and it is very much harmful to the environment. So hydrogen sulfide is an extremely toxic and flammable gas, and it will be like it is a very much toxic to the environment also. So under temperature, some hydrogen sulfide is going to react with steam. this hydrogen sulfide is reacts with steam and it is going to produce the sulfuric acid. Then it will be have the some significant effects on the useful life of a LFG plant. So this and then what happen, it will be having some significant effects on the useful life of a LFG, landfill gas plant. So hydrogen sulfide removal is very important because this hydrogen sulfide is an extremely toxic and flammable gas, and it will be having negative effect on the environment also. So under some temperature and hydrogen sulfide, this is going to react with some steam to produce the sulfuric acid that has significant effects on the useful life of the landfill gas plant. So because of this, hydrogen sulfide removal is very important. So you can see this table. It is a comparison of the economics of various methods of landfill gas desulfurization. So this is the table this table will represent the rate and the capital expenditure and operating cost for the desulfurization method. So for desulfurization method, if it will be involved with some biological agents, like some microbes will be there, biological agent. So if some biological agent will be involved, like some microbes, so in this way what happened, the rate will be medium and the capital is also, expenditure is also medium, but its operating cost is very low. So the biological desulfurization methods is the best method when we see the capital expenditure, operating cost. Next is the treatment with some iron chloride. So treatment with iron chloride is like medium and its capital expenditure is also very low and operating cost is medium. Same thing is there, that is for water washing. So for water washing, the throughout rate is high, capital expenditure is also high and the operating cost is minimum. In case of activated, if we use the activated carbon methods, then the rate is high, capital expenditure is also high and operating cost is also medium. So in case of iron oxide or some hydro oxides, and in case of sodium hydroxide, like the rate is also high. So when we go with some water washing, some activated carbon methods or iron oxide, so these, in this way what happened, the throughout rate is high and capital expenditure is sometimes high also and the operating cost is medium or less. So this is a comparison of economics about the various methods of landfill gas desulfurization and which methods can be adopted. It is based on the operating cost also. Then next is the other landfill gas contaminants. We'll talk about some other contaminants. We have talked about sulfur and hydrogen sulfide. And for this sulfur and hydrogen sulfide, the best method which will be used is the adsorption methods. So now we will discuss about some other contaminants like ammonia, aromatic hydrocarbons like benzene, toluene, ethylene and xylene, BTEX, that we have already discussed. Next is the halogens. So landfill gas will also contains this type of contaminants like ammonia, aromatic, BTEX and halogens. These contaminants are usually present in landfill gas at concentration below the detection level. So they are present in the landfill gas, but its detection limit is very less. It is below the detection level. This concentration is below the detection level. So the concentration of ammonia is below 0.1 mg per meter cube. The concentration of ammonia is below 0.1 mg per meter cube. That of some aromatic hydrocarbons below 1 mg per meter cube, and some halogens, that of halogens below 0.1 mg per meter cube. So it will be facilitating immediate use of gas without the need of any additional treatment required. So it will be facilitating the immediate use of gas without the need for any additional treatment system. So this concentration of ammonia is like 0.1 mg meter cube. So that will be having some aromatic hydrocarbons. And this aromatic hydrocarbon is like, it will be below 1 mg per meter cube. And for some halogen, 0.1 mg per meter cube, facilitating the immediate use of gas without the need for any additional treatment system. So then we'll discuss about the landfill gas energy technology. What are the different technology that has been used for the landfill gas energy? So there are several ways to effectively utilize landfill gas for energy. First one, in a boiler we can use, or by some direct thermal application, or by some leachate evaporation. In the boiler is the most common type of direct use and can often be easily converted to use landfill gas alone or in combination with some fossil fuels. It is the most common type of direct use and it can be easily converted to use landfill gas and alone or combination with some fossil fuel. So in boiler is the most common type of direct use, and in this boiler you either you can use it directly or you can use it by adding some fossil fuel also. So a next method is the direct thermal application. So in the direct thermal application, what happen? It will include some kiln like cement, pottery, bricks will be there, and sludge dryer, infrared heater, paint shop, and some oven burner, tunnel, furnace, process heater, and blacksmithing. Four is two. These are some few names. In this, we can utilize this landfill gas energy. Leachate evaporation, in which the combustion device that uses landfill gas is used to evaporate leachate. Leachate is like the liquid that percolates through the landfill. So this leachate evaporation can reduce the cost and treatment of disposal of leachate also. So this, if we utilize this methane into the evaporation of leachate, so one device will be there on the landfill site. So from that device, we'll utilize the methane for the treatment of leachate. And as we already know, leachate is a liquid that will percolate from the solid waste dump site and it will enters to the groundwater or some subsurface water. So if we will utilize this methane gas production to the treatment of leachate by leachate evaporation, so this is another very much beneficial use for the methane gas also, and it will tackle out the treatment process for the leachate also. So next energy is the biomethane production. So biomethane production in a gaseous fuel with some physico-chemical properties similar to those of natural gas that make it possible to inject it into the gas grid. Methane is a gaseous fuel, obviously, and the physico-chemical properties are similar to those of some natural gas. This methane will have physico-chemical property that will be similar to some natural gas, and that is making it possible to inject it into the gas grid. So this LFG can be upgraded to biomethane by removing the carbon dioxide and trace contaminants such as ammonia, hydrogen sulfide. So CO2, NH3 and H2S. These are the contaminants that has been removed, and then this landfill gas can be upgraded to biomethane by removing this contaminant. So when we remove the contaminants like carbon dioxide, ammonia, hydrogen sulfide and some siloxane, this methane can be used as a biomethane. So for below are some of the property that can be used for the CO2 removal from landfill gas, and it can be employed to remove the energy value of the fuel. First one is the pressure swing adsorption method, PSA method, physical and chemical adsorption, membrane separation, cryogenic treatment methods, and the process are different only in terms of utilized techniques. So pressure swing adsorption method, this is the best method. PSA, pressure swing adsorption method. So this process are different not only in terms of utilized technique but also in terms of achievable gas quality, the processing behavior and the experience with which they have been used in landfill gas processing. So the processing of this landfill gas is required, and these processing are different only in terms of utilized technique from where these gas are going to be utilized. So it will depends upon the utilization technique. So methane will be there. Methane, it will be depend upon its utilization, where it is going to be utilized, like in industry or for the removal of for boiler, where you are utilizing this energy, this methane gas will tell about where it has been used. So the processing behavior and the experience with which they have been used in landfill gas processing. You can see this is the overview of CO2 removal process. So for nitrogen removal processes, as for carbon dioxide removal, as we already discussed about this pressure swing adsorption, PSA method. So adsorption of CO2, a very low molecular sieve will be there. Next is the physical absorption. So pressurized wash water. Pressurized water will be there, and dissolution of CO2 in water at a very high pressure. Next is the chemical absorption. So in chemical absorption, it is like monoethylenamine will be there, that is used for the washing. Then the chemical reaction will be CO2 and MEA. Polymer membrane gas separation. Membrane separation will be there. In that membrane separation, polymer membrane gas separation is there, that is dry only, and membrane gas separation, that is wet only. So membrane permeability of H2S and CO2 is higher than the methane. So this method is used because the membrane permeability of this hydrogen sulfide and carbon dioxide is higher than the methane, and its final methane content is like that. Next is the cryogenic process. In cryogenic process, low temperature pressure process will be there, and for this what happened, the phase transformation of CO2 to liquid, while methane remains the gases, and its final moisture content, methane content will get is more than 99%. So adsorption method by PSA is a very useful method, and this cryogenic process is also very good method. So these are the overview of some carbon dioxide removal processes. Next is the following is the list of some common reason for controlling the gas produced by the landfill. So what are the reason that will be useful to control the gas produced from the landfill? So first is like that it will prevent the air pollution and comply with the regulatory air emission criteria. It is going to reduce the hazards due to off-site migration and prevents the damage to the landfill cover slope stability. Next is the odor control, energy recovery, and prevent vegetation distress. So these are the following list of some common reasons for controlling the gas produced by the landfill. So to control the gas produced by the landfill, these are some of the common reasons. First is it prevents the air pollution and comply with regulatory air emission criteria, and reduces hazards due to off-site migration. Prevent damage to the landfill and cover the slope stability. Odor control and energy recovery, that is going to prevent the vegetation distress. So the air pollution and comply with some regulatory air emission criteria. So these are some list of the common reasons. So in this class, we have discussed about the contaminants removal from the landfill gas. So main contaminant that will be required to remove is the hydrogen sulfide, some amount of ammonia, some amount of sulfur. Then only this methane we can use for the biomethane, or then only we can use this methane in the industry or from air any places. And some of the reason for controlling gas produced by the landfill, we need to control the landfill to reduce the production of gases, because what happened, it is going to prevent the air pollution and comply with some regulatory air emission criteria, reduces some hazards due to off-site migration, and it prevents damage to the landfill cover slope stability. It is going to prevent the damage of the landfill covers, that will be covering the slope stability. Next is the odor control. Odor control is also important, and then energy recovery, like it will prevent the vegetation distress. So these are the reason that will be very important reason to control the landfill gas or to control the methane and carbon dioxide and hydrogen sulfide production from the landfill. Now this is the reference of some of the textbook that you can follow for the depth study of this subject. You can go out throughout this textbook, and you can explore the topic more. Then from there you will get more information. Okay. So now I'm concluding my lecture at this remark, like, in this lecture I have discussed about the removal of contaminants from the methane. Because why it is required? It is required because when we are using the methane for other purposes, like for electricity generation, like for we are using the methane in the industry, in the boiler generation, so that contaminant should be removed. And what are the methods that has been involved to remove these contaminants from the methane gas? Like for siloxane, some adsorption methods will be there, like physical adsorption method, PSA method will be there. In case of all these contaminants, mostly adsorption method has been followed. So if you have any query or if you have any question regarding this lecture, you can write in the comment box, or you can mail me onto my given mail id, shikha.pandey@gmail.com. And I have already given you some of the references of some of the textbook. In this, you can go to Gilbert Master, where you will get a very depth and study of these topics, and you can explore more on the topic. Okay. Thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.